Hello everyone, today let's solve the problem LionAge 2, right? So this was asked in the Codeforces beta round 66. So you can just go through the question, it's easier to understand. I'll just this one, what do we call? I'll just summarize the question so that it will be easier for us to solve the problem, right? So you can just go through the question. Let me summarize the question for now. This one, so just give me a second here, 1 second. Yeah. So we are given a non-empty lowercase string s. So non-empty word is very important. We are given a non-empty lowercase string s and then integer k basically, right? So k means maximum letter that changes, right? So maximum letter that changes, that is nothing but the k, and string s is nothing but the non-empty lowercase, this one, string s basically, right? So for each adjacent pair of letters, see this one, x y, there is bonus c of x comma y. It can be negative as well, right? So for the each adjacent pair of letters x comma x y, basically there is a bonus, this one, we call this one as this one, you can write it on this way, c of x comma y. So it may be negative basically. We may change at most k characters of s. We may change at most k characters of s basically to any lowercase letters to maximize the total sum of bonuses over all the adjacent pairs, right? So we may change at most k characters of s to any lowercase letters to maximize the total sum of bonuses over all the adjacent pairs, right? So we have to output that maximum, right? So we have to output that maximum. So that's what the question states here. Again, I'll just read out the question loud. Just listen to this carefully, right? So we are given a non-empty lowercase string s and then integer k. This one I'm speaking of. For each adjacent pair of letters x, y, there is a bonus c of x comma y. So it may be negative as well. They have strictly mentioned in the question. And also we may change at most k characters of s. This one, we may change at most k characters of s. K we have been already given here, this k, right? So we may change at most k characters of s to any lowercase letters to maximize the total sum of the bonuses overall adjacent pairs, right? So we have to output the maximum, right? So we have to output the basically maximum. So this is the question, simple, right? So this is the simple one basically. Let me remove this one entirely. So this is rated 1800, yeah, somewhat simple. This is fine. Now let's do one thing. Let's come to the input. So they have given here winner 4, so we have 4 inputs here. So we have SE7 0, this one OS8, LO13 and 008 here. The output that we need to get here is the maximum is 36, right? So this is for the input output part. Let's do one thing. We are familiar with the question in the input output. Now let's do one thing. Let's quickly discuss the, what do we call, approach followed by the complexities, and then let's write the code, right? So let's consider the same this one, first input for the approach basically, right? So this one, right? So we have s here, we have winner. This winner is nothing but s basically, string, right? String s, we have winner, and k we have been given 4. So this one we have discussed in the question basically, s and k. So string we have been given winner and k we have been given 4, and the bonuses that we have here is this one, right? So and the bonuses that we have here for one SE7 followed by these 3 lines, right? So this is fine, right? So this is fine. SE we have this one, what do we call, SE we have 7, OS we have 8, LO we have 13, the last one here again, LO we have 13, OO we have 8, right? So the value bonuses, this is fine, man, right? So here we can change at most 4 letters because k we have been given 4 here, right? So this one I'm speaking of, k we have been given 4. This is fine, we know this. Accordingly with the question, we can change at most 4 letters, right? So best target string here is this one, loser basically, right? So we have SE, OS, LO and LO. So basically total we have L 4 times O, S E S, right? So this one we can change at most 4 letters. The best string here is this one, loser basically. I'll just go with LOOSER, right? So this one, this is fine. So we will be going with a W plus L, I to 0, n to 0 and n plus 5 will remain this one unchanged. So see, I can just represent in this way, w to l and this one I to o basically. So this is fine. So n to o as well, we can change at most 4, right? This one n to o and n to s, this one we can change to make this one as loser basically, right? So this one e and r remains unchanged, e and r remains, so this one unchanged, right? So this one I'll just write it here, unchanged, right? So this one is fine, man. Yep. W, we are changing this one to L, I to O, N to O, and N to S basically. So this one remains unchanged. So we chooses exactly 4 changes, right? So this is fine. Adjacent bonuses for the loser is LO. This one LO, we will be assigning this one to 13. So OO, this one we have 8. OS, this one will be 8 as well, and SE to the 7 as per the input, and ER to 0 because this remains unchanged, right? So this is ER to 0. We have changed for this one basically, right? So we have changed 4 letters, W to L, I to 0, I to O, N to O, and N to S basically. This is fine. Now what we'll be doing, the sum would be, so we have to sum up this one, right? So this is 13, this is 8, this is 8, and this is 7. When we sum up 13, 8 plus 7 plus finally this one 0 as well, we have to consider this is unchanged, right? So this one will lead to the output 36 basically. We have to sum up this one, 13 plus 8 is nothing but here 21, 21 plus 8 is nothing but 29, 29 plus 7 is nothing but this one 36, right? So we have got the output 36 basically, right? So this is the optimal one. So this is the optimal one. So this will be returning as output. Basically, we have got the output 36, which is equivalent to the output that they have given for the example 1 within the question, right? So we have got the output 36, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So one more thing. So to solve this particular problem, we'll be going with a DP. So I have just showed you the calculation part basically. So how we will be making use of the DP, that will be for this particular problem, we'll be seeing that one directly within the code itself, right? So the DP idea, so I'll be discussing that one while writing the code itself for this one, right? So this is fine, I believe. So usually I discuss that one first itself. For this particular problem, I'll just go with the this one. I'll just explain the DP idea while writing the code itself, right? So this is fine. Just remember that to solve this particular problem, we'll be mainly going with a dynamic programming approach. This is fine, I believe, right? So let's move on with the complexities part, man, before starting this one, before writing the code basically. So what will be the time complexity here? The time complexity would lead to big O of n into k into 26 into 26, right? So n into k into 26 into 26 basically, right? So this is fine. So this is the time complexity. What would be the space complexity? The space complexity would lead to big O of n into k into 26, right? So big O of n into k into 26. This is fine. So this is the space complexity. So the time complexity and the space complexity for the code that we'll be writing in the future would be n into k into 26 into 26. This one time complexity, because for each position and the change count, we will be looping over previous letter, nothing but the 26, and current letter, nothing but 26, right? So this one time complexity would lead to this one. And what would be the space complexity? Space complexity would be n into k into 26, because we'll be storing dp of n into k plus 1 into 26 basically, plus this one v of 26 26. So overall space complexity would lead to this one, n into k into 26. So this is fine, I believe. So this will be the time complexity and the space complexity. So now, as we are completely familiar with the approach and complexities, we are good to write the code. Let's start writing the code, right? So I'll just come here. So first thing is we'll be making use of the fast input and output, right? So this is fine. Just give me a second, 1 second. Yeah, I'll just import the input output star. This is fine. We'll be making use of the different utility packages as well. So I'll just go with java.util.star. So this is fine. So let's go with the class, sorry, so this one, let me go with class main. So within the main class, so within the main, so yeah, within the main class, or the main method, or the class, yeah, within the main class, let's do one thing. uh, let's go with the sentinel for impossible or very small values, right? So you can just give any class name here, this doesn't matter. This just give some class name that's relevant to the question basically. So within the class, first let's do one thing, let's go with the sentinel for impossible or very small value, right? So I'll just go with the static here. So this one final, I'll just go with long negative, I'll just go with a G, neg here. So this one, let me go with long, 1e 10 to the power of 18. So I'll just go with 1e 18. So this is fine, I believe. Let's go with the main method. So let me make use of the throws exception, or else we'll be getting the error. So I'll just go with throws exception. So within the main method, first let's move on with a fast input reader, right? So I'll just go with buffered reader br equals new buffered reader. So this one will be new input stream reader. So this one system.n. so this is fine, and we'll be going with a print writer. So this one will be pw, or let me do one thing, this is related to the output, right? So I'll just go with the out. So this one will be new print writer. So this is fine. So this one will be system dot output. So this is also fine. So next let's go with the string tokenizer one. So I'll just go with string tokenizer. So this one st equals new string tokenizer buffered reader dot read line. So this is also fine. So let me go with the original name string here. So this one will be string s equals string tokenizer dot next token. So this one will be next token. So this is the original name string. So this is fine. So the next one would be let's go with the max allowed changes. So this one will be int k equals integer dot %. So this is fine. String tokenizer dot next token. So this is also fine. Yep. Let's go with the number of bonus pairs that is given. So this one will be m. We have already discussed this one. So this one is also of the type integer. So I'll just go with % of again buffered reader dot read line. So this is fine. Next step would be, so we have to go with the bonus table, nothing but v of xy for the pair x comma y. So by default it will be 0, right? So let's go with the initialization part. So this one will be v equals new long of 26. So we have not discussed, we had not discussed the this one dp idea. I'll be discussing this one directly while writing the code itself, right? So I said we'll be going with the dynamic programming, so we don't have to worry about it. So let's move on with the this one iteration part. So this will be for int I equals 0, I less than let me increment the I. So within the for loop string tokenizer, this one will be new string tokenizer. So this one will be buffered reader dot read line. So this is fine, and let me go with char a equals, so string tokenizer dot this one will be next token. Let me make use of caret as well. I'll just go with caret. So this one has to be at the first index, nothing but 0. Also let me go with b initially, right? So this one will be string tokenizer dot next token. Again let me make use of caret here. So this one will be 0, right? So this is fine, I believe. So this is nothing but the letters, right? So we have to go with the bonus value also, and if you remember the approach, I said that the bonus value can be negative as well, right? So this one let me assign x to, so this is integer, right? So integer dot %, again string tokenizer dot next token. So this is fine. And finally we have to store this one in the within the 26 indices. Nothing but index starts from the 0. This is 0 based, not 1 based, right? So this will be 0 to 25 basically indexing. This one a hyphen a, this is fine. So b hyphen a, this is also fine. Yep, so this one, let me assign this one to the x basically, right? So this is fine, man. Yep, let me come out of this one entirely. Now let's go with the length of the string, meaning, so I'll just initialize the end to s dot length. So this will be fine, man. Yep, so this is fine. Now let's do one thing. Let me go with the dp of ijc, nothing but the maximum euphony for the prefix up to the index I, also using exactly j changes and total, and the ith character is c here, meaning we'll be going with a let me go with a dp array here. So we have discussed this one basically. So this will be of the size n k plus 1 and the 26 letters, right? So this will be in this format, long this dp equals, so this one will be new long of n, so this one will be k plus 1 and also finally 26. So this is fine, this is fine. We have to initialize all the states to the negative, nothing but the impossible. So let me go with the for loop here. So this one will be int I equals 0, I less than n. So let me increment I here. So again one more for loop, this one will be int j equals 0, j less than or equal to k, and finally let me increment the j, right? So this one, let me give arrays dot fill dp of ij, this is also fine, neg, this is fine, man. Yep. Now let's do one thing, let's initialize the position 0, nothing but the first character here. So I'll just go with for int c equals 0, c less than 26, c plus plus. So within the for loop, if we change the first character to letter c, that consumes one change. So here j has to be greater than or equal to 1, right? So one more thing is, so 0, we have to go with the 0 euphony here since we don't have any adjacent pairs. So I'll just go with one more for loop here. So this one has to be just give me a second here, and for j equals 1, j less than or equal to k, and let me increment j. So this one has to be dp of 0, j c, let me assign this one to the 0. This is fine. Now if c equals the original first character, then we have used 0 changes, meaning, so here if c equals s dot let me go with caret here, caret 0 hyphen a, then what we need to do, I'll just assign dp of 0 0 c to the this one 0. This is fine. Yep, now we are fine. So just note one thing here, dp of 0 0 and say this one other letters stays negative, meaning it cannot have 0 changes and different character, right? So just note this point. So this is very important as well. So now let's fill the dp, right? So for the position 1 to n minus 1 basically. So this is the main part, right? So this is the main part and this is the only part basically, right? So just let's fill the dp for the positions 1 to n minus 1. So I'll just go with for here, and I equals 1, I less than n. So this one will be I plus plus. So again one more for loop for int j equals 0, j less than or equal to k, j plus plus. So one more for loop for int x equals 0, x less than 26. So this one will be x plus plus. So this is fine. So previous character at I minus 1 is letter x, right? So this is what int x equals 0, x less than 26, x plus plus. This is fine, man. So j is nothing but the j is number of changes that is used so far. We know this one. Finally, within the for loop, what we need to do, if it is unreachable state, then we have to skip. So how can I write that one in the form of code? So let me write the simple if condition here. If dp of I minus 1, so this one j, this one x, so this one equals negative, then let me do one thing. Let me give continue here. Continue. So this is fine. So let me carry on with the further this one. Let's move on with the further steps. Let's move on with the for loop here. So let's go with the for loop, simple for loop. So this will be for int y equals 0, y less than 26. So this one will be y plus plus. So this is fine, man. So within this for loop, so let me go with a simple if condition. If y equals s dot, let me make use of caret here, nothing but the index I hyphen a. So this is fine. Here in simple terms, if y equals the original letter at I, we don't consume any new change, right? So we can just go with the transition from dpi minus 1 jx to the dpi jy, right? Also we need to add the bonus v of xy. Just remember this one, right? So I can just write it on this way. Just give me a second here. Did I miss anything? No? I'm feeling like I'm having a feeling that I missed something. No? So let's do one thing. I'll just go with the dp of I, sorry, dp of I j, this one y, ijy. So this one will be math dot max of dp of I j, this is also fine, y, comma dp of I minus 1, this is fine, j, so this is also fine, this is x, plus v of x comma xy. So this is fine. Yep. Now let's do one thing. Additionally, there is a possibility of carrying a beta value, right? So this one, let me write one more if condition here, man. Yeah, this is fine. So code will be lengthier. So this one, if j is greater than 0, then dp of I, j and y. So this one, let me go with math dot max of this one, dp of I, j and y. So comma dp of I, and also we'll be going with a j minus 1, and this one has to be y. So this is fine. So else what we will do, else let me make use of else if. So what if the j is greater than 0, right? So then what we need to do, so in simple terms, if y is not equal to the original s of I, then we must spend one change for the current position, right? So the transition comes from, this time the transition comes from dp of I minus 1 into j minus 1 into x, right? So basically one fewer change used, that is used in the prefix. So I'll just go with the dp of I, j and y, right? So this one will be dp of I, j and y. So this one I can just write it on this way, math dot max of dp of I, j as well as considering y, and this time we'll be going with a comma dp of I minus 1 j minus 1 x, I minus 1 j minus 1, and this one has to be x, right? So this is fine, plus v of this one x, so this one will be y. So this is fine, I believe. Also we need to allow carrying the best from dp of I into j minus 1 into y as above, right? So how can I write this one in the form of code? So this one will be the last one, I believe. So again, so let me copy the same thing, man, here and make the necessary changes. So let me copy this one entire thing. So this one remains dp of I, j, y itself. So this one will remain math.max same. Dp of I, j, y remains same. Dp of I, this one has to be dp of I, j minus 1. J minus 1 along with the y, that's it, right? So we don't need b of x y here. So this is fine, I believe. Somewhere I must something, man. Dot max. So this one basically, the parenthesis, closing parenthesis. So this is fine. So we are left with only few things now. Let me come out of this one entirely. This one, yeah. Now answer is nothing but the maximum over letter C for the dp of n minus 1, k and c, right? So this is used exactly less than or equal to k changes, right? Basically dp includes the carried states as well. So first initially let's do one thing. We have to go with the result variable, right? Result variable I'll consider answer here, and let me assign this one to the negative instead, right? Not 0. I'll just assign this one to the negative because they have said that this one it can be negative, right? So I have explained this one. I had explained this one during the approach as well. It can consist of negative numbers basically. So we'll not be considering 0 here. We'll be going with the negative basically. Let's go with the iteration part here. So this one will be for int c equals 0, c less than 26, c plus plus, right? So this is fine. Let me assign answer to math.max of answer comma dp of n minus 1 and also kc. So this one will be k, this one will be c. This is fine, man. Now let's we have to print the result as well as we have to flush the output buffer. So this one will be out dot println. So this one has to be, let me pass the answer here, out dot flush. This one has to be, yeah, this is fine, man. We have just print the result and we have flushed the output buffer. So we are done with the coding part, man. So this time I hope this is correct. So before checking the code with the different inputs or the examples, let me do one thing. Let me copy paste the signature starter template. So I'll just come here, let me paste this one. Yeah, this is fine, man. Let's do one thing. Let me copy this one entirely. So the output that we need to get here is 36, right? So let's check the same. So I hope this works, man. We have buffer. Oh, this one, why I have given e equals here. Line number 37 buffered reader dot read line. This is fine. Let me run this one again. We are left with one error. M has to be capital here. Line number 60. Let me make M capital here. So this is fine. Let me run this one again. So yeah, we are getting the output 36, right? So now this is correct. There were some typos, 2 typos. Basically this is fine. So output that we need to get here is 20. Let's check the same here. Yep, we are getting the correct output for the 2 examples that they have given in the question. So we are getting the desired output, right? So this is fine. Now let me copy this one entirely. Let me come to the question. Let me hit the submit button here. Let me paste the code. Just let's wait for some time, man. This is taking time. Just give me a second here. So yeah, I'll just come here. Let me paste the code here and let me hit the submit button. I hope this works for all the test cases, man. Let's see. Let's wait for some time. This was the simple one. Not completely simple, very simple, but yeah, solvable. Just in the toast it is showing accepted, right? So the verdict that we got here as accepted basically. So we have made use of the pure DP to solve this particular problem, right? I hope the solution part is completely clear, man, along with the approach and the complexities. For now, this is it. Thanks for watching, guys.